All right, we're in section 5.4 where we're going to be asking to multiply fractions. Okay, so if you notice here, we have essentially the same problem, but we're going to solve it out two different ways. Okay, first way we'll look at is right here and look at it without the manipulatives. So what we have is 3/5 times it by a quarter. All right. Now, what makes multiplication of fractions a little bit easier than like adding or subtracting is the denominators do not have to be the same. They don't have to be common in order to multiply them. Okay, so what we get to do is we get to just multiply them across and then reduce from there. So all I got to do is multiply 3 to 1. In this case, I just have to multiply um, 5 times 4. So when I do that, 3 times 1 is 3, and 5 times 4 is 20. And then reducing from there, 3/20 is reduced, excuse me, and that is my answer. So a lot of people always seem to ask, when you're multiplying, shouldn't the values be larger? Well, it's not necessarily the case when it comes to fractions. So if you look here in this box, all right, this box represents like one whole of something. So one whole box, like, or you could talk about, like, usually people talk about like fractions, they talk about slice of pizza, or they talk about portions of a variety of different things. So this whole rectangle, even though it's divided into different sections, is one whole. Okay, so that's one. All right, so now let's look at this value right here, 3/5. Okay, so right now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 20 separate rectangles within our whole. Okay, that is another way that I can represent 3/5. All right, so if I put 20 on the bottom, that means we have 20 individual ones. In this case, I multiplied by 4 here, so that means I have to multiply by 4 here, so I get 12. So of this whole, all I'm going to look at is 12 of those individual rectangles. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Those are the only ones that we're going to look at. Okay, and so from each individual rectangle, we are going to take a quarter from that. So basically, like, this is a quarter, this would be a quarter, this would be a quarter, this would be a quarter, here's a quarter, here, 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 and then finally here and here. Okay, so we have 12 different quarters. All right, well, quarters deals with 4, so I take that 12 divided by 4, that ends up equaling 3. So if you were to add up all of these quarters, you would get 3 full rectangles. So that's why I can say that this is going to be 3/20, because you're still dealing with the whole, but you're only multiplying it by those 3/5. Okay, so that's not normally how we would multiply them. We would definitely multiply it this way. This way is easier, um, conceptually, and we can kind of go from there. So in this case here, uh, we have a product of two fractions. One's positive, one's negative. The rules still remain the same, but sometimes what we want to do is we can do some reducing before we do any multiplying. All right, so what I'm saying is I look at each individual numerator and denominator, and I want to see if there's something that's divisible by uh, each number that's in the numerator and denominator. And so if I look, I notice that 7 and 21 are both divisible by 3. So what I'm going to do is I'm going to divide 21 by 3, which will give me 7, and I will divide 7 divided by 7, and that will give me 1. All right. 4 and 10, I know, are both divisible by 2. Actually, it's negative 4 because of the negative right here. So it's actually negative 4 and 10. So negative 4 divided by 2 is going to be negative 2. And 10 divided by 2 would give me 5. All right. And then from there, we can multiply across 2 times negative 2, which is negative 2, and 5 times 7, which would get us 35. Okay, and so it's already reduced. Um, you certainly can multiply it across and then reduce it from there, but this is just another way. Okay, so looking at these particular fractions here, I have 2/3 times by 7/8. I notice that 2 and 8 are both divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. 3 and 7 don't go anywhere, so I just leave them as is. 1 times 7 is 7, and 3 times 4 is 12. Okay. From here, looking at 3/4, when I like to do these, when I see a fraction being multiplied by an integer, I will rewrite it as a fraction. So I'll just put it over 1 and then multiply it from there. Looking at this, I have 4 and negative 12. Both of them are divisible by 4. 4, oh, excuse me, sorry. 4 divided by 4 is 1, and negative 12 divided by 4 is negative 3, which then gives me negative 9 over 1, which then can be reduced to just negative 9. If you left it as negative 9 over 1, that's okay, but to simplify it even further, put it just as the integer negative 9. All right, now we have a mixed number multiplication. All right, so we have 3 and 2/7 times by 2 and 1/2. Same thing we talked about when we were multiplying, or when we were adding or subtracting. For multiplying, you'll do the same thing, just put it into an improper fraction. So 3 times 7 is 21, add 2, so I get 23 over 7, and that gets times it by 2 times 2, which is 4, add 1, that's 5, so that's 5 over 2. And then you just multiply it accordingly. Looking at this, 23 and 2, no. 23 and 7, no. 5, 7, 5, 2, no. So this is a situation where I can't cancel out any numbers, which means that whatever my result is, so 23 times 5 is 15, and 7 times 2 is 14, this is going to be in lowest terms. And if I wanted to rewrite this as a mixed number, 115 goes into 14 8 times, so I got my 14 here, and then 8 times 14 is 112, so that leaves me with 3. So if you left it as the improper fraction, 115 over 14, fine. If you read it as 8 and 3/14, that's great as well. Okay, so basically this is just telling you what we just did. Anytime we're multiplying mixed numbers, you must change the numbers into improper fraction, and then finally reduce or change the answer back to a mixed number when necessary. Okay, so let's look at this one. This one's a little bit different because we have an integer. Like I said, always rewrite it as a fraction. And so in this case, I can write it as 10 over 1. And then it'll get multiplied by the improper fraction. So I got 11 times 2, which is 22, and then 23, 24, 25. So 25 over 11. Okay, looking at this, 10 and 1, 10, 11, no, 25 and 1, 25 and 11, no. So there's nothing I can reduce. So this will turn into 250 in the numerator and 11 in the denominator. Okay. If I want to rewrite it as the mixed number, I will then say that 250 divided by 11, that goes in there 22 times. And then I put it over here. So 22 times it by 11 is what, 242. 250 minus 242 gives us 8. So I have either 22 and 8/11ths and over 250 over 11. All right, last thing we can look at is multiplying fractions that include variables. Um, Still the same process. You can cancel anything out that you may want to. Um, that'll help you reduce it. But in this case, you can multiply variables and numbers together and create those variable coefficients. Okay. So for the first one, I got m divided by 3 times by negative 15 divided by 5. Looking at this right off the bat, I noticed that that negative 15 and 5, they both are divisible by 5. So this goes into 1. This goes into, looks like, a negative 3. And also here are negative 3 and 3. They both go into 3. This goes to be 1. This goes to be negative 1. Multiply it across. I got 1 in the denominator, and I got negative m in the numerator, which would result into simplified as just negative m. The second example, 3y divided by 4 times it by y to the fifth divided by 9. Looking over here, right off the bat, nothing I can cancel out. So I'll just multiply it across. 3y times by y to the fifth would be 3y to the sixth. Remember from chapter 4, you add the exponents, and then um, 4 times 9 is 36. And I made a mistake. 3 and 9 do actually go together, so I do have to reduce this. And both 3 and 36 are both divisible by 3, which means that this will turn into y to the sixth all divided by 12 because I divided by 3 here and I divided by 3 here. All right. Looking on the bottom, let's look at this problem here. So I have 3z to the fifth divided by 25 times by 2z to the fourth divided by 15. All right. What do I notice? So 325, no, 3 and 15, yes. So both of them are divisible by 3. This turns into a 5. This turns into a 1. 2 and 25, no. So I can multiply it across. 2 times 1 is 2. And then z to the fifth times by z to the fourth would be z to the ninth by adding the exponents together during multiplication. And then 25 times 5 is 125. And that would be in lowest terms. And that is being able to multiply fractions. Hope this helps. Until next time.